Are you ready for the Quanah FFA Skills Team? Good afternoon. We are Quanah FFA Senior Skills Demonstration Team. My name is Kinnaman Horton, and these are my friends Clancy Bagby, Alan Walther, and Harper O'Neill. Good afternoon.
Our demonstration today will consist of measuring, marking, cutting, reaming, threading, preparing joints, and assembling pipe and pipe fittings. The Texas SEC that our skill covers is 301.62, and it can be found under Act Structures in Plumbing.
Each of these is a skill within itself, but they all must be compiled into one skill in order to do the simplest of plumbing jobs around the house or farm.
If the plumbing skill that we demonstrate to you today was practice or proficiency, it would not qualify you as a certified plumber, but it would save you much labor, time, and money.
You can do this skill on your farm or home with a set of plumbing skills similar to the ones we'll be demonstrating with today. This skill is basic to plumbing work.
Steel pipe is more rigid than other types of pipe and should be used in places where it will have to be self-supporting or where it will receive abuse from livestock. The steel pipe we are using today costs approximately $2.50 per foot.
Copper tubing is flexible and can be run around irregular parts of the building. Because of its flexibility, it is not easily damaged by freezing as steel. A copper tubing system is much more corrosion resistant than galvanized steel, but must be run in an area protected from damage.
It can be joined by flare fittings, compression fittings, and sweating. A half-inch copper tubing costs approximately $3 per foot.
With galvanized steel pipe, we will be using our pipe vise to hold our pipe, our pipe cutter to cut the pipe, the reamer to ream the pipe, the threader to thread the pipe, open in and pipe wrenches to tighten the pipe and screw on certain fittings.
With copper tubing, we'll be using a tubing cutter to cut and flare the tubing, and a flare tool to prepare one end to attach to a flare fitting. We'll also be using torch and solder to join the tubing.
All of the tools we're using today can be bought at your local hardware store, plumbing shop, or any home improvement store such as Lowe's or Home Depot.
We will now begin our demonstration by calling your attention to this simple stand.
Let us assume that this stand is a portion of a water system found in your home or on your farm. A freeze has caused the pipe to burst in two different areas.
For the simplicity of our demonstration, let us also assume that the broken pipe has already been removed. First, we will measure the distance between the two fittings and add half an inch where the pipe will screw into the fittings.
In this instance, the pipe will need to be cut 18.5 inches.
When the exact length of the pipe needed has been determined, a mark should be made on the pipe. A permanent marker will best do this.
Pencil and chalk marks are often used, but are temporary because they can be easily rubbed off. Our mark does not rub off.
Perfect.
Our pipe is now ready to be cut. Today, we will be using a pipe cutter consisting of 2 rollers, a cutting wheel, and a handle. A hacksaw could also be used, but we found that our method is much safer and leads to smoother cut.
We will place the pipe in the vise with the mark about 6 inches from the vise. Tighten the turning handle until the 2 rollers and the cutting wheel are firmly against the pipe and the wheel is on the mark.
Oil the pipe and keep it well oiled during the cutting process. The oil acts as a lubricant and helps keep down the heat during friction.
Tighten the turning handle approximately 1/4 turn each revolution of the cutter around the pipe. Do not turn the cutter too fast or an excessive burr will result inside the pipe. The pipe is now properly cut. Compare this cut with one made with a hacksaw.
The pipe should be reamed after it is cut to remove any burrs caused by the cutter. If the the burr is not removed, it will partially obstruct the full flow of water. Now observe as Ken and May ring the pipe. The cutting edges on the reamer are made to be turned clockwise. All of the burrs should be removed. The remaining process shall continue until no raised place can be felt on the inside of the pipe. Tap the pipe on the vise to remove any metal shavings. We will now compare this pipe with one that has not been ringed.
We will now begin threading our pipe. Clamp the vise and push the proper size guide over the end of the pipe. Apply inward pressure forward on the die. Once the die is engaged, the inward pressure may be discontinued. Oil the pipe and keep it well oiled throughout the threading process. This helps keep down excessive heat, and it helps push out the metal shavings. Our die has 3 sets of cutting blades with spaces between them for the metal shavings to drop. Your blade must be in good condition for satisfactory work. You will know you are done threading when the pipe is flush and not over 1 thread over the line. And that is true for the 1/2 inch pipe we are using today. For 1 inch or larger pipes, the number of threads will need to be increased.
Back the die carefully by turning it to the left. Do not use undue pressure when backing out the die. Chips may fall into threads, causing the die to catch. If this happens, turn it to the right again. When all pressure is off the die, you may complete the backing out process by unscrewing the die by hand. Be sure not to remove the die before it is completely backed off, or you may cause damage to the die and the threads.
Tap the pipe on the vise slightly to remove any loose particles. Your pipe is now properly threaded. Here is a selection of the most common fittings used in plumbing work. A union and coupling will be necessary when assembling a galvanized steel pipe. A union will enable this line to be taken apart later if necessary. Whenever possible, screw the fittings on the pipe while it is clamped in the pipe vise.
Screw the fittings in the pipe together by hand as much as possible to prevent cross-threading.
We will first, before doing that though, we will apply our Teflon tape. Sealant compound could also be used, but we found that Teflon tape creates a faster seal. However, if you want your thread to be taken apart often, you should use machine oil. Or for a more permanent hold, use a commercial compound.
Screw our fittings in our pipe together by hand as much as possible to prevent cross-threading. Use open-end wrenches on the fittings that have a shoulder to prevent the rearing of the fitting.
As the pipe and fittings are tightened, the Teflon tape will spread to fill the threads. Note that we're using wrenches on both the pipe and pipe blade to keep from twisting the pipe and breaking the already sewed threads. The pipe threads are tapered, which will make a watertight connection.
We will then start our union by hand. Our union has a brass seat which makes for a watertight connection. We will then tighten the union with open end wrenches because of their shoulders. This will ensure that the airtight connection has no leakage points. And just like that, our galvanized steel pipe is now repaired.
We'll now turn our attention to the second broken line. Instead of replacing this line with galvanized steel pipe, we will be using copper tubing. To show copper tubing's versatility, we will use two different types of fittings.
To repair the second broken line, we'll first need to measure the distance between the flare fitting, and the end of the copper tubing.
In this instance, the copper tubing will need to be cut 14 and 5 inches.
To cut our copper tubing, we'll be using a tubing cutter. A tubing cutter is much like a pipe cutter in the way that it has a handle, two rollers, and a cutting wheel. However, when using a tubing cutter, you must remember not to turn the handle too tight, or you will have a crushed piece of tubing. To do this, you could also use an electric tubing cutter, but tools are expensive. We will now observe as Harper cuts our tubing. We will compare this cut with one made where the tubing cutter was over tightened. Next, we will observe as Allie reams the tubing with a triangle-shaped reamer on the back of the tubing cutter.
To assemble the tubing, we will first flare one end of the copper tubing using a flaring tool. Slide the copper tubing through the bottom hole of the split block used for 1/2-inch tubing. Slide the compression screw up and lock it in place above the copper tubing. Be sure that your split block is secure so that the tubing does not slip out. Tighten your compression screw clockwise until it releases and turns freely. Back your compression screw off by turning it to the left. Release your compression screw from the block and slide it back and remove your tubing. This end is now ready to be installed.
We will use a coupling and a solder to attach the other end of the copper tubing. You should always have a Class ABC fire extinguisher on hand when working with any flammable materials. Any good soldering job starts with the proper preparation of the joints to be soldered. First, clean the ends of the tubing with a wire brush or steel wool. Next, clean the inside of the fitting, in this case, the coupling. Apply coating of flux to the ends of the tubing and the inside of the coupling. Failure to properly complete either of these steps will result in a leaky connection.
Next, you'll put one piece of copper tubing into another piece of copper tubing using lead-free solder and a propane torch.
First, though, we will tighten our fitting to make sure that there are no leaks.
You will start by turning on your propane torch by cracking your valve and pulling the trigger. You will start by heating up your copper tubing until the lead-free solder copper tubing, it is now repaired.
A plumbing repair job is never complete until all connections have been checked and all leaks have been stopped.
We will now check to see if our connection is watertight. We will use an air tank to put 40 to 60 pounds of pressure onto the lines. Our line should hold at least 40 pounds, which is normal water pressure.
We will now release our air.
Lacey, what can you tell us about galvanized steel pipe?
When you're working with galvanized steel pipe, you should always remember to use the correct wrenches and keep your pipe oiled during the cutting and threading processes. It is also imperative that you do not forget your sealing compound or Teflon tape.
Harper, what can you tell us about copper tubing?
Remember that copper tubing is very flexible and can be used more easily in irregular parts of a building. Also, your copper tubing should be of good quality and very corrosion resistant. You want your copper tubing to have a life expectancy of 60 to 80 years and only be used in well-protected areas.
We have now completed the steps in repairing a broken water line on the home or in the farm. We are now done except for cleanup. Thank you so much.